Put yourselves positioned for a boundless disaster of exceptional extent. Underneath the purple Gaia CB, changed on the edge of our structure, it is passing on troubling messages through the universe. Using the James Webb Space Telescope, cosmologists have decided something fundamentally agitating about this critical huge body. As astrophysicist Brian Cox offers a grave affirmation, the inquiry-weaving machines say we are on the slant of seeing an unfortunate gun-not impact influence that may forever change the night sky to the degree that we can be occupied. We ought to dive into the astounding woven craftsmanship of the universe, where stars are thought about, live, and pass on in beautiful plans. One superstar has really gotten the imagination and type of cosmologists, and the public the same. This notable star is a red monster of gigantic extent and age coordinated obviously within the amazing body. Its undeniable tan variety and intricacy have for a really long time been a wellspring of interest. Later advancements have supported interest in this great monster, as we find the probability of an approaching awesome event in the current example of this star. Paying little heed to what these activities may suggest, we may be on the cusp of seeing a perpetual presentation of unbelievable scale. More than our sun, it is a sublime behemoth. Its full enormous size is almost beyond human ability to grasp. Imagine a star so enormous that if it were to displace our sun, its surface would extend past the circle of Mars, overwhelming Mercury, Venus, Earth, and Mars in its imminent hug. This isn't simply an uncommon presentation of the star's genuine characteristics, but in addition tends to its stage in the brilliant life cycle. As a red giant, it is in the night of its presence, a phase portrayed by expansion and cooling following a lifetime spent combining hydrogen into helium in its center. However, what might be said about the age of this megastar? Estimated to be around 8.8 to 8.5 million years old, it is relatively youthful in human terms yet old concerning heavenly lifetimes. It is in the red giant stage, a consequence of millions of years of heavenly advancement set apart by significant changes and cycles that have changed it from a hot blue star to the red monster we see today. The current case of stars, like this one, is a story of improvement driven by the consistent forces of atomic combination and gravity. Its sketchy bronze variety is another sign of its constant stage. The red tone is a consequence of its somewhat cooler surface temperature contrasted with other stars like our Sun. While the Sun's surface temperature is around 5,500 K, this star's cooler surface registers temperatures around 3,500 K. This cooler temperature gives the star a red appearance. However, this tone isn't simply a visual element. It gives scraps of data about the star's condition and the cycles occurring inside, adding to the star's character. What further enhances its identity is its variable nature. Old Roman and Chinese work suggested that about 1,000 years ago, it became yellow. It was in the 900s that Arabic cosmologists first described it as red. This variety shift over human history isn't just a detail in the annals of cosmology, but also a sign of the star's tremendous changes. The variable brilliance of the star is another spellbinding viewpoint. It is a semi-regular variable star, meaning its light periodically fluctuates. This changeability is a grandiose dance of brilliance that has captivated stargazers and skywatchers for hundreds of years. Typically, the star undergoes a multi-day cycle alongside a longer cycle that stretches around 5 years. These cycles were recorded as far back as 1836 by Sir John Herschel, and likely even earlier in local oral traditions. What makes this star mysterious isn't simply its changing brilliance, but its predictability. Unlike many stars that follow predictable patterns, it inconsistently strays from its rhythmic darkening and lighting up, illustrating unpredictable and less understood processes happening inside its structure. Recent discoveries have caught the attention of cosmologists and stargazers universally, with a captivating change in its appearance. An event known as the extraordinary darkening occurred in late 2019 when the red giant, one of the most striking stars in the night sky, began to diminish mysteriously. The star's diminishing was pronounced to such an extent that it began losing its shine at a significant rate, reaching its lowest brightness in February 2020. Normally visible to the untrained eye even in light-polluted areas, the star became observably fainter, a change detectable even to amateur spectators. However, there is one challenge with attempting to figure out the events of this star: the time oddity. When we observe a star like this, we are not seeing it as it exists in the present, but as it was in the past due to the time it takes for light to travel to us. In this star's case, at around 725 light-years away, the light we see today left the star almost 7 centuries ago. This deferment makes it challenging to predict and make sense of unexpected changes in a star's behavior, as we are essentially looking into its past. The extraordinary darkening event served as a delineation of the innate hardships of cosmic observations and the limitations of our insight while managing tremendous cosmic scales and the time peculiarities they present. This was firmly seen by Andrea Dupree, head of the Center for Astrophysics at Harvard and Smithsonian, and her team. They used Hubble to dissect the star as part of a 3-year study to examine variations in its outer climate. These observations provided outstanding insights into the dynamic dynamics of a variable star like this one, which regularly expands and contracts, causing changes in brilliance. Hubble's aversion to light allowed the scientists to examine the layers above the star's surface, which were warmed essentially by the star's wild convection cells. Further investigation of the Hubble spectra taken at specific points during 2019 and 2020 revealed the movement of material in the star's outer climate. Particularly, the spectra focused on magnesium lines, which are typical for celestial conditions. These observations showed material moving at speeds of around 200,000 miles per hour from the star's surface into its outer climate. This hot, dense material eventually extended thousands of miles from the star and formed a cloud that caused the star's diminishing. Dupree and her team estimated that twice the normal amount of material from the star's southern hemisphere was lost over the 3 months of the eruption. This mass loss was significant, especially since, like all stars, this one regularly loses mass, but at a much higher rate than our Sun. The size of this mass launch and the subsequent dimming sparked conversations among cosmologists about whether this event could be a forerunner to an enormous blast. The vicinity of the star, around 725 light-years from Earth, adds to the interest as such a blast would be visible from Earth and provide a great opportunity to witness a grandiose event very close. However, this still has yet to be addressed conclusively. What does this event mean for our understanding of the universe and its celestial phenomena? Could this be a sign of a supernova, a catastrophic event that marks the explosive death of a massive star? Supernovae are among the most powerful events in the universe, releasing immense amounts of energy and synthesizing elements crucial for life, such as oxygen and iron. If this red supergiant were to undergo a supernova event, it would likely briefly outshine an entire galaxy and become visible across vast distances, potentially even during daylight on Earth. The study of such events not only contributes to our understanding of stellar evolution, but also provides insights into the composition and dynamics of the universe. Supernovae are essential for dispersing heavy elements created in stars throughout space, enriching future generations of stars and planetary systems. For astronomers and astrophysicists, studying stars like this red supergiant offers a window into the final stages of the stellar life cycle and the cataclysmic events that shape galaxies. By observing changes in its brightness, spectral emissions, and mass loss, researchers can refine models of stellar evolution and better predict the behaviors of similar stars in the cosmos. Moreover, events like the extraordinary darkening of the star highlight the importance of long-term observational studies and the capabilities of advanced telescopes like the Hubble Space Telescope. These instruments enable scientists to capture detailed data and analyze complex processes occurring millions of light-years away, providing unprecedented insights into the workings of the universe. As our understanding of stars and galaxies continues to evolve, each new observation and discovery adds to the tapestry of knowledge about our place in the cosmos. The study of cosmic phenomena, like the red supergiant, and its potential supernova event not only fascinates us with its grandeur, but also deepens our appreciation for the intricate mechanisms governing the universe's vast expanse. In conclusion, while the future behavior of this red supergiant remains uncertain, its recent extraordinary dimming serves as a poignant reminder of the dynamic and ever-changing nature of the cosmos. By continuing to explore and study such celestial events, scientists are poised to uncover more of the universe's secrets and expand humanity's collective understanding of the cosmos and our place within it. The diminishing occasion means, for the star's future, is it an indication of a looming cosmic explosion or just an exceptional episode in the star's long and complex life? A few hypotheses have been proposed to make sense of this surprising change. One conspicuous hypothesis proposed a stage in the cosmic explosion process, a speculation that builds up forward movement due to the inescapable conviction that the star is approaching the finish of its life. Another critical hypothesis involved dust, perhaps from the actual star. Like other red supermonsters, it is believed to shed material, and it was trusted that this material could shape a residue cloud thick enough to impede the star's light from our point of view. A third clarification considered changes in the star's photosphere, the noticeable external layer, which could influence its brightness.